Hello and welcome to Math 8, Unit 1A, Lesson 5. Today's objective is scholars will convert terminating and non-terminating decimals into fractions. Okay, so what are terminating and non-terminating decimals? Terminating simply means they end. 0.25 is a terminating or ending decimal. 0.333333 forever and ever and ever, notice the dots tell you it goes on forever, is non-terminating, unending. We also would write this as 0.3 and we put the repeat bar above it. So how do we convert terminating decimals? So those are easy, right? So terminating decimals, we simply look at where the last digit is. So 0.25, the last digit, this 5, is in the hundredths place. Remember, it's tenths, hundredths, thousandths, and so on and so forth. So we're just going to put 25 over 100, and then we can reduce it. So that's 25 over 100. And I know that 5 goes into both of those, so that changes to 5 over 20. And I know 5 goes into both of those. It becomes 1 over 4. Guys, this is a quarter. That is why a quarter is worth 25 cents. 1/4 is 0.25. Okay, what about this one? This next one, 0.5. The last digit is in the tenths place, so you simply put the 5 over the 10. 5 over 10. Again, I know 5 goes into both of them, so it becomes 5 divided by 5 is 1. 10 divided by 5 is 2. 1/2. Well, what about this one right here? 0.125. The last digit is the thousandths place. So you simply put 125 over 1,000. 125 over 1,000. I know 25 goes into each of these. So that is 5 over, so it goes into 100 4 times 10 over 40. Well, again, now I know that 5 goes into both of those. So 5 goes into 5 once. 5 goes into 40 8 times. So it is simply 1/8. Now, some of these you guys might know already. But this is just a way to turn them back to the fractions. So now, what do we do with non-terminating decimals? Something like 0.33333 forever. So what we're going to do is we have to get rid of that repeat. So we're going to say that x is equal to whatever that value is. In this case, 0.333. If we multiply x by 10, we know that 10x is 3.333. We moved our decimal. So now I have 10x is 3.33 ... And x is 0.33 ... We can simply subtract those from each other. So 10x minus x is 9x. 3.333 repeating minus 0.333 repeating. That part's going to cancel, and I'm left with 3. So now I have 9x equals 3. So if I divide both sides by 9, I get x equals 3 over 9. The big thing is at this point, please don't put that in your calculator because you're going to be right back to there if you give you that. So I need to reduce this. So I know that they can both be divided by 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. So 1/3 is the value. You guys know that 0.3 repeating is 1/3. Let's try another. So here I have 0.454545. So I'm going to set x is going to be our 0.454545. 100x is going to be 45. This time I have to move it too so that my decimals line up. So if you see here, 100x is 45.4545. X is 0.4545. Notice these cancel. So that will go away. When I subtract, I get 99x equals 45. Again, I divide both sides by the coefficient of x. And I end up with x is 45 over 99. Now, 9 goes into both of those. So 45 divided by 9 is 5. 99 divided by 5 is 11. So that's my answer is 5 over 11. Okay, let's look at one more. What about this one? Where only the second digit repeats. So this is 0.4666666666 forever. So in this case, I'm going to multiply by 10 and multiply by 100. So I have 100x equals 46.6666 ... 10x equals 4.6666 ... Again, I am subtracting. 100x minus 10x is 90x. 46, this part cancels. 46 minus 4 is 42. So I get x equals 42 over 90. And again, this is, at this point, just a matter of reducing it. So I know that 3 goes into both of these. So 3 goes into 42 14 times. 3 goes into 90 30 times. So then those can be reduced again by 2. So this is 7 over 15. So let's talk about some patterns here. So if we look at these problems, you'll notice when we have one digit repeating, we do 10x minus x, which always gives us a 9 on the bottom of our fraction. So this is 4/9. When we have two numbers repeating, we do 100x minus x. So we always have a 99 on the bottom. And if just the second number keeps repeating, we do 100x minus 10x, which means we end up with a 90 on the bottom. Now, all of this, of course, is before we reduce. So please watch for these patterns, and you'll see what happens. So here I have 51 over 99. For 90, it gets a little bit complicated because we end up with 75 minus 7.5. So here we end up with a 67 over 90. Okay, so watch for those patterns. When just one number repeats, it's over 9. Two numbers repeating is over 99. Second number repeating is over 90. Okay, do the practice problems, and I will see you in class.